Good morning, good afternoon, good evening, wherever you may be hailing from. This is the CIQ webinar series, and we are live today as of April 2nd, 2026. Yeah, that's right, folks. 2026 is already a third of the way over, but we are just getting started here at CIQ. March was a crazy busy month. We had RLC Pro, RLC Plus, some partnership announcements, the CLK Kernel C3 announcement. Well, technically that was today, but one of the big things that we came out with last month, in the month of March, was actually RLC Pro AI. So what we're talking about today is how do you maximize the throughput of your AI infrastructure? And it wouldn't be a webinar unless I bring in a few friends of mine, some folks that are brilliant in their field and really enjoy engaging with them. But before I introduce my panel of guests today, there are a lot of them. Today, I'm excited to share that we are live. And so there is a chat function, and so if you click on comments, feel free to say hello and where you're from. If you have questions throughout, make sure that you throw your questions in there, and we'll do our best to address those as we go along today. If not, towards the bottom of the hour, we'll try and cover as many questions as we can live. That said, let me bring in Mr. Brian Dawson. Brian, you finally made it onto the CIQ webinar series with me. I appreciate you joining me today.
Great to join you, Eric, and yeah, excited. I end up missing a couple. It's exciting to jump on this new iteration of CIQ content. To take a minute to introduce myself, I am Brian Dawson. I am a director of product management within our Linux area within CIQ. And in particular, I've been focused on our workload optimized variants. And the one I'm excited to talk about today is the one that me and the team have spent months on tuning and bringing to market. And that's RLC Linux from CIQ Pro AI, oftentimes referred to in short as Pro AI. So looking forward to talking about that with you today, Eric.
Awesome, Brian. Thank you for joining me. Also joining us today from CIQ is Mr. Damon Knight. Damon, welcome to the CIQ webinar.
Hey, Eric. Wonderful to be here. Everybody, my name is Damon Knight. I am a senior principal automation engineer at CIQ, and I'm also kind of our all-around AI nerd.
And nerd among other things, as I found out in a recent podcast interview with you. So, but I won't open up that can of worms. We only have an hour. And also joining us is our friend Zach. Zach, you don't work for CIQ, and we'd love to find out where you do work and a little bit about yourself.
Yeah, I'm Zach. I'm from AI Insight Solutions, which is an AI consulting firm. I help startups to medium-sized companies build cool things with AI and machine learning. As Damien said, I'm also a huge AI nerd, and I'm excited to be here today for the conversation.
Awesome. Yeah, glad you could carve out some time and join us. There's it's the technology industry can become a little bit of an echo chamber, so it's nice to get some outside opinions, and your advice has been invaluable as we've been working on Pro AI. Once again, if you are watching us live, there is the chat function, so feel free to throw a greeting out there, and then if you have questions as we dive into today's topic, would love to hear your questions. Let's see. All right, sorry, I forgot to pull up my notes. I'm doing great as a host. So first, before I ask my panel our first question, I'm actually going to ask the audience a question. So how are you managing your CUDA driver stack today? And so I'm just going to throw in a multiple choice question there in the chat. So if you are watching, why don't you just read that question and answer A, B, C, or D in chat? Really curious to see how folks are using their current stack. And while those answers are coming in, Brian, I want to start with you. I really want that high level industry focus that you bring to the table. And so question number one for today is, where are most organizations right now when it comes to GPU infrastructure and getting AI into production? That's not just running, that's in production.
Yeah, and I'll go back a little bit and describe what I've observed after a number of interviews, months of research, is that what we're finding with production is we've talked about, we've been on this technology evolution that is much more compressed or moving much faster than those who have been at this for a while have really ever seen before. And what that has sort of led into is people needing to move fast, begin experimentation, and move to production very quickly and faster than people have necessarily had the ability to build from ground up what the optimal AI infrastructure looks like. So what I am seeing very frequently is that many people started experimentation on the cloud, right? Hard to get GPUs, easiest place to sort of secure GPUs and hardware to work. They started to build and then quickly move into production. And they found, okay, yes, we found some business value, but we've also found that if we don't intelligently manage spend, this is expensive. People have then started to acquire GPUs, realize that they need to move at least some of their workloads on-prem. And then now people are encountering, okay, I was able to outsource stack concerns to things like AI Foundry. I was able to not worry about performance because we were up tuning the model level. And now they're in a world where they have to figure out how to instantiate or reinstantiate or mimic this infrastructure that they started out on internally within their own traditional IT operations.
That's awesome. Zach, is that kind of what you've seen from the industry as well?
Yeah, I've seen a lot of similar things. A lot of orgs I work with, when the spend question comes up, you look at, all right, how many bucks are we spending per hour? Let's just go buy some GPUs and stick them in a box and put them under somebody's desk. And now you've solved one problem, perhaps you've got a fixed spend, but now you've created a whole another set of problems for yourself. The thing sounds like a jet engine. It's heating up the office. The monitors stopped working when you updated the CUDA drivers, and the guy knows how to fix it is out for the rest of the way. So yeah, there are no easy answers. There's a lot of people working very hard to keep their stacks running so they can do their job.
Well, and the one thing that the Brian and Zach missed was then the sysadmin and networking teams are looking at the IP address for that random box and going, "Where is this? It's not in a rack anywhere."
Yeah. Well, the old days of shadow IT. I thought of my early career, the first iteration of CDW, right, where you just buy a box and ship it under your desk because you didn't want to wait for central IT anymore. But we're getting a version of that, of what Zach said, right? And that's actually great from an AI ML perspective, right? I need to move workloads over. I'm doing experimentation. Now this thing is real. I got to mitigate the shadow IT. So now I'm going to our central IT organization, our Linux system administrators, and I'm going, hey, I need you to take this over. I need you to rack these cards, rack these machines, metaphorically speaking. And what I'm hearing from many of the system administrators is, Debian, I don't know how to run Debian. Cards, right? And there's this whole new stack that people have to figure out sort of how to set up. I would add briefly that, another state that we're seeing is people have, as someone's used an analogy for, people are figuring out how to drive a Prius, right? I'm just trying to get on the track and do a couple of laps. And we are now starting to move to the place where we have to get into performant cars, right? We're now going to take high speed laps around the track. So you see people going, okay, look, my Prius was sitting in a container. I got my general structure going. Now I need to figure out how to squeeze the most out of it, right? How do I get it to perform? How do I get it to be stable? How do I enable myself to utilize the most of my GPUs that we spent significant money on?
And I agree. It's, if AI is going to prove itself to be a legitimate tool, and I think it will be. We may not quite be there yet, but I think it will prove to be a legitimate tool. And the real question, though, is how much time right now is an AI and or systems administration team actually spending building the infrastructure versus actually using the models that they're building?
Yeah, I'm going to take a lead on that and then I want to throw it to Damon. I'm just going to say I'm hearing a range. I will, I'll throw it to Damon, who could maybe underline this or correct it. But I heard that on a happy path to set up sort of my golden image or one server, that is going to be a couple of hours. I personally have heard and experienced that can actually span across days to get your GPU set up and running. So I'm hearing it's been painful for people. But luckily, we have our resident AI ML nerd here that has had to do it many a times.
It's not fun. A lot of us, might remember the early days of kind of IT being a thing, right? To some of your earlier points about things being the Wild West, and the AI world still feels a whole lot like that right now, where nothing is standardized, nothing works the same way. There's very little abstraction, and so yeah, it takes a lot of time potentially to even just figure out what you need for the stuff that you've got handy, right? No one thinks about the time that you're going to spend Googling how to install everything when they plan this stuff out. But the fact of the matter is, actually, you're probably going to spend more time Googling how to install everything than you are installing it, which will also still be more time than you spend using it, at least for a while. So it's bad. Even for someone like me who's done this a million times and has written scripts to do it for me, it's still 10-15 minutes on a really good day to get a single box up and running with CUDA and the right drivers. That's best case scenario, where I've already done the work and I'm basically hitting enter.
Yeah, I can relate to that. The first time I set up a local LLM, it probably took about 3 days off and on trying to get things to work. And then even after things worked, it wasn't getting the performance that I was expecting. And it was pretty brutal. So I can definitely say that in my time trying to run local AI, I spent more time, probably 90% more time focused on getting the thing set up than actually doing anything productive with it. How about from the advisory perspective, Zach? How long do people usually take to get to that first inference?
Yeah, I mean, I think Damon put it pretty well. Like, everything goes well, it's under an hour. You remember what you're doing, you do it all in the correct order, you get all the steps right, and there you go. You've got the CUDA drivers, you've got the box running, everything works. It never goes right, though. My experience is always something along the lines of, oh, we updated the CUDA drivers. This literally happened to me once, and now the monitor doesn't work. So you can still SSH into the box, but good luck if you want to, connect a keyboard and mouse and a monitor to it and actually like log into it, the way a normal person would with a computer at their desk. So it's all over the place. It's always an adventure you're going on, whether you want to or not.
For sure.
I'd say you think about, when we're all excited, I think about a very personal experience, right? Whether you're talking rack scale or you're talking my Dell. I'm excited. I got my Dell. I'm ready. I'm going to load some models. I'm going to run. Next thing I'm down in grub configs, blacklisting drivers.
Right. I'm taking photos with my phone with ChatGPT so I can say what is this screen and how do I get to the place where I need to change the thing I'm trying to do? Yeah.
I think you guys have been watching me as I work in my home lab. So here's the problem. An hour or 4 hours may not sound like a lot, but the problem is I don't have just one AI box. I have like 50 of them, all with multi-$1,000 cards. As a systems administrator or AI engineer, I don't have that kind of time to spend on each box fighting things through. Why not just take an AI workload and put it on a typical server? I mean, that works out fine, doesn't it? What do you think, Damon?
I mean, if you don't mind the job outlasting the heat death of the universe, then that's probably a good plan. It's AI workloads, and I know I'm preaching to the choir a little bit here, but AI workloads are very different from what historically data centers and data processing folks have really dealt with, right? Unless you were doing something special with, video processing or whatever, where you needed, ASICs or some sort of special hardware, things generally have all just been running on general purpose CPU, utilizing that processor, utilizing your system memory, all of that. And so your OS spends its time managing the CPU and the memory and those resources. And when you start going into AI workloads, really the CPU and the system memory have nothing to do with it, right? You've got that big fancy GPU that you've spent more than a house on, and you want all of the processing to stay there the whole time. You don't want to be offloading stuff. You don't want to be swapping stuff around. You don't want to be communicating or spending kernel time. And so that's a really big shift. Also, scaling becomes a whole lot harder, right? There are hardware constraints. We all know the difficulty of getting GPUs. Just have more, just throw more at it. These options all kind of go out the window in this brave new world that we find ourselves in today.
Yeah, Risk to add. It's interesting that you say, right, like when you're talking general purpose, hey, I need a server that's a mail server. I need to run a database, right? The whole idea of vertical versus horizontal scaling is just different in nature, right?
Yeah.
Than how do I horizontally or vertically scale an AI workload, right? I'm generally looking to take a general purpose Linux OS, deploy it to serve as many use cases as possible, and occasionally fiddle a couple of bits. My job is based on this server is stable, right? So yes, I have all the services running. I'm making sure that my IRQ or my interrupt prioritization is right, so everybody gets attention. As Damon says, it's a very different universe for AI. And look, the reality is for understandable reasons, people weren't too concerned with that. They were driving their Prius around the track. Right now, they have to figure out how to get it to act like a Ferrari. But the reality is something like 52% of AI workloads are actually running on a general purpose OS.
Yeah.
So we kind of hinted at a couple of the different steps, but Damon, can you walk us through, if I do take my general purpose ISO, I just go out to rockylinux.org and I grab the community edition. What's kind of that process to getting from nothing to something?
It's not easy. Generally speaking, right, you're going to be making sure you have your Linux kernel headers and development libraries installed. You have to go find the right, just straight up normal NVIDIA driver versions that support your hardware, which is not necessarily as easy as you might think. You have to go find the right CUDA version. You might be going, Damon, the drivers ship with CUDA. There's CUDA, and then there's the CUDA toolkit. There's a whole separate thing that you need if you're going to be dealing with AI and ML workloads. I've told this story to Eric before, but I'll tell it again. If you're an Ubuntu user, and up until just recently, 24 was the LTS and 25 was kind of the bleeding edge. And if you ran Ubuntu 25 and you went to the official sources, there was no CUDA toolkit for Ubuntu 25. You had to know that you were supposed to install the Ubuntu 24 CUDA toolkit. Good luck to you if you didn't, but you needed to know that, right? And then, okay, do you have the right torch installed? And was it compiled against your CPU or the GPU? I sure hope it was the GPU. Otherwise, you're not actually using it, and you have a big, expensive, power-hungry paperweight. There's a lot of steps involved to get to actually, taking that OS and getting to tokens being generated.
So Zach, is that kind of what you found with some of your clients?
Yeah,
Or is
yeah.
there
I
some
mean,
kind of hidden costs that people are having to pay?
it's like that meme of the guy with the whiteboard and all the strings. Like you're in a room somewhere trying to write out the matrix of, okay, we got this card, and it'd be really nice with monitor work. So which driver will do both, both of those things with the CUDA version we want. And also, I'd like my monitor to work. And then the torch drivers, the two CUDA. I mean, I can't tell you how many conversations I have with IT departments where it's like, okay, great. The CUDA drivers are on the drivers are on the machine. You should be good to go. And then I come back. I'm like, yeah, actually, I need CUDA too. Okay, a couple days go by. All right, we got CUDA too. All right, great. I actually need the CUDNN libraries as well. Do you have those? Oh wait, no, they're not compatible. Like, and so you're back. And by the time you build the stack up to, all right, now I'm at Torch with the right version of the toolkit, with the right version of CUDA, with the right version of the drivers, with the right GPU. How many back and forths in that cycle have gone through? How much just human time have you burned, like getting all the version numbers lined up and everything talking to each other and plumbing your data from, Torch at the Python level down to your GPU.
Well, and not just the human time, but the trade-off time is brutal. Because
yeah.
that your infrastructure team goes in, they fill a request, they close it, they move on to the next thing, and then you come back a couple of days later and go, oh, I need this extra thing or this extra thing, and then it takes a couple of days to get through that process again. So the handoff time is just murder when you have to keep going back to IT.
Right. Yeah. I mean, it's just, and you're speaking different languages. Like you've got, data scientists and ML people talking about, CNNs over here that they want to run because they're doing an image problem. And you've got some of the IT department over here who's like, I don't know, looking at a thermal graph from a server and saying this thing's going to melt itself.
So I feel like there's got to be a better way to do this, Brian. I feel like if only some company out there somewhere had a cool idea and fixed this problem.
You know what I think would be really cool? It's a great idea here. I think what would be really cool is if someone was able to simplify all of that dependency management, validation, kernel mod building, tuning of PyTorch flags, and then packaging it. That would be awesome, so that I can just get an ISO or a cloud image and I could hit install, and then I can download Olama and I can get some tokens out of it. That would be really cool. And in fact, that is what this team here at CIQ has done in terms of building and delivering RLC Linux from CIQ Pro AI. Is build a image or a variant of our trusted RLC Linux that will enable people from Damon to Zach and even me to be able to grab an image, put it on a box, and be able to be getting tokens returned from an inference server in as little as 3.5 minutes. So I think we've solved that problem, Eric. I think we've solved that problem.
So, Damon, I want you to kind of tee up the demonstration that we have going, because this is going to take some time to run, and I don't want to spend a good chunk of our hour together. So if you can kind of tee up the longer version of what we're getting ready to show here.
Yeah. So, I've talked a little bit about, kind of that happy path, that best case scenario where someone has a script ready to go to do all of the things. And I do have one of those scripts, and we've got a couple of systems. We have a Ubuntu, I think it was a 24 system, maybe a 25, I forget. And we have an RLC Pro AI system, both with identical hardware, identical configurations, A30 GPUs, I believe is what we're going for this demo here, and just kind of really helps you all see the difference in completely fresh install, right? Same state for both, to that kind of time to first token, first inference. And I think we have a little demo that shows it talking about AI, in fact.
Yeah, and so I'm just gonna leave this here. We're gonna let this run. This is the Ubuntu system that Damon was talking about. Not to pick on Ubuntu, but it's just it's what we've been testing with. So while that's
Honestly, if I can too, for folks,
Sure.
we picked Ubuntu because honestly, right, in the AI space historically, that's where folks have gone first, right? Because of the kind of community support and all of that. So we really wanted to make sure that we were comparing this to the thing that most people are using today.
So Brian, I wanted to circle back now that we've kind of got our cooking show set up here. Well, we're gonna let Ubuntu cook for a little bit, and so while that's cooking, I wanted to circle back to something that you said. You used the term validated, and I think that's really important. And I want to call that out. There's one thing to just go in, download a bunch of drivers on a version that you think will work, but validated is a whole nother level. You wanted to talk about validation a little bit?
Yeah. And if I may, that's actually a good time for me to pull back up a bit and just kind of give a once over of RLC Pro AI and what it is, right? We've talked about some of the problems that people are experiencing, setup time, that has opportunity cost. It has, up to $3 a GPU hour hardware sitting there. We have performance left on the table, right? As we all have just talked about. So what RLC Pro AI is it is a AI workload tuned version of Rocky Linux and effectively Rocky Linux from CIQ that enables people to set up a system and getting it running in as little as minutes. It pulls forward the latest upstream stable kernel, where you will find that vendors are committing support for current or emerging hardware so that you can get the most out of that hardware's features. And it's enterprise Linux. So it is enterprise Linux such that people that have invested their time working in RHEL and have a need for stability in the enterprise are able to get the balance of speed and stability. Now we get to where we lean into validated. One of the things that we have done, and as Damon sort of called out, I think we learned during the process is more painful than I ever would have assumed, right? Is we pulled in everything you need in the stack, right? And we started with an initial stack and we will be expanding that. But right now, that means we pulled in the latest upstream kernel. We brought in all of the K mods for NVIDIA and then soon AMD as we've announced our partnership. We've brought in the CUDA toolkit. We've brought in some of the other user space requirements. We've brought in PyTorch. We've recompiled PyTorch, benchmarked it, and tuned the flags. And switched flags to make sure we were getting the most out of the GPU throughput for production inference that we could. Now that's great. We've put all of that together, but the keyword validated is okay. Throw in PyTorch, throw in a K mod, throw in the latest kernel. Next thing you now have to do is make sure that all works together. And to something Damon indicated earlier, that, hey, great, we didn't throw this stack together and just kind of get it to work, but we've left all your performance and utilization on the table and your system's running hot. So what we've done is we've validated that from a dependency standpoint, these things work together. We've also validated that from an operation and performance standpoint, that it is performant.
So Damon, what can happen to a system that hasn't gone through this validation process, where it is just kind of duct tape and hopes and dreams that are keeping all the version numbers aligned?
Well, I did mention a little bit of it earlier, right? But a really, I think, somewhat frighteningly common one is that whole torch piece, right? It's really, really common to wind up not running your GPU-enabled torch like you think you are, and to actually be sending all of your AI workloads to your CPU. And you go pull up and NVIDIA SMI. You go, why is my GPU sitting at 0% utilization? And why am I generating half a token a second? This seems odd. But that's a really, really common occurrence. Brian mentioned that we compiled Torch with flags, right? When you're running inference, you're going to see all kinds of messages pop up for, oh, hey, you don't have flash attention compiled, so we're doing this in a silly, slow way. Again, our validation, our testing, we enabled these flags, we've run the benchmarks, we've run the tests, we've seen that this stuff actually is working together and is using the right optimizations and setting all the things to the right places so that you don't waste your time, again, looking and going, boy, where are all of my tokens going?
Well, and I love the fact that the engineering team has spent so much time testing out these different versions, introducing these different flags. But it actually goes a lot deeper than that, in that we aren't shipping the standard Rocky Linux kernel. So part of our announcements in March was the CIQ Linux kernel, or CLK kernel. Brian, you want to talk to us about what the CLK kernel is?
Yeah. So what the CLK kernel is we'll call it out of tree, right? And I think many of our audience probably knows this. But traditionally, if you're an enterprise Linux distribution that is downstream of Red Hat Enterprise Linux, or RHEL, through that overall stream, you are pulling your kernel from kernel.org. Now, Enterprise Linux traditionally and rightfully is very focused on stability, right? We are running business critical enterprise workloads. So we intentionally in that space don't rev too fast. So we are careful about the timeline. It's different with each distro, right? At which you pull forward kernels from upstream kernel.org. So what is Click? Click is CIQ Linux kernel. Currently, it is at 6.12. We will shortly, in a couple of weeks here, be releasing 6.18. And what it is, and what that is as fast as we can follow the latest stable upstream kernel from kernel.org that we bring down, we rebuild, and we sign, and then we vendor back and support it, right? Validate it, bug test it, and it is vendor backed. And again, as I said earlier, what is the value of that is because now you're in a situation where you're getting the latest performance enhancements, primarily in terms of hardware support. And for where many of us are concerned are GPUs, but also in terms of IO scheduling, storage scheduling. Right, it's under continuous improvement. So what we're able to do with sort of our deep enterprise Linux experience, as well as pulling forward and productizing this thing we call CLK or Click, is we're giving a balance of the stability of enterprise Linux, but speed that gives you a performance advantage, and even more so enables you to increase your GPU utilization by leveraging advanced features day one out of the box by as much as 30 to 50%, going off an industry stat that says most GPUs are underutilized by as much as 30 to 50%. Now, to be perfectly honest, that's for various reasons, right? It's your data piping, it's your pipeline, it's your kernel. But what we are looking to do is take a material chunk out of properly supporting your expensive hardware, so you are getting more utilization.
Awesome. So, Damon, why don't we jump back towards our demo here and kind of walk us through what's been going on over the last 8 or so minutes that the Ubuntu box has been plugging along?
Yeah, we've made quite a bit of progress, actually. We've gotten the NVIDIA drivers have been installed, CUDA has been installed. At the moment, I believe it is doing all of the Torch setup and installation.
So I see my CUDNN libraries installing. That's great.
Yep. So I think we're getting pretty close to the end here. Next up, I think is going to be doing installation of transformers and some other things. We'll see what I typed. Yeah, look at that, transformers.
Hey, look at you.
Then once these install, I think it's finally ready to kick off the actual demo and start generating some tokens.
And
We're
Zach,
getting
is this a case like you brought up CDU, and is this a case where and I hear this, so I want to ask you as an AI ML engineer, you asked for your build or your image, you get it, and the framework or library needs not there, and that's that trip that Eric talked about where you're going
right in the middle there. And so someone's gone through, like this is everything worked, but it probably didn't take 8 minutes to put this stack of commands together and figure out what do I run in what order. And so someone's going to go back and rerun this process and insert some steps in the middle. And that's not always as easy as, just running it again, So yeah, it is, there are a lot of parts to put together. It's easy to forget one. It's like the IKEA couch, you put it together and there's a couple of screws left on the table and you hope those weren't the important ones.
That's funny.
You can see here, actually, we've finally we have moved on to the actual generation demo. It's just loading all the models up now. So we're any minute now, we're going to start seeing actual tokens from Ubuntu.
So how long do you think it took you to build this demo, to Zach's point, Damon?
Oh, I don't know that I could even begin to guess. This lovely script was a product of months and months and months of me doing more installs than I care to remember. I'm pretty sure I wake up in the middle of the night screaming CUDA in a cold sweat.
Yeah, so just copy paste alone, we're up around 12 minutes here, and we still haven't gotten to ask any questions of our AI model. So we'll let that run a little bit longer. So why don't we go ahead and talk about what comes next? So it's fetching files. It's kind of it's doing some downloads. What can we expect next, Damon?
Well, I said next, we're going to see actual generation. The script is written up here. So basically, it's running a very, very small Quen model, and we're going to ask it about LLMs, I believe, is the question that we ask it about. And we're going to see, some answers and some information being generated for us here. But, the joy of AI, I'm sure you all know, is downloading those models. You can see here, this is a 16.4 gigabyte file here. So it does, unfortunately, take a little bit, even on a pretty fast connection.
And that's a relatively small one. I joke with my friends and people ask me what I do for work. It's, well, I watch progress bars on the command line in many different forms.
I've unfortunately been playing with some of the very large models that are 400, 500 gigabytes inside.
Oh, gosh.
And yeah, you start the downloads and it's go for a walk. But okay, here we go.
Yeah, I do
it is generating some tokens.
And I will have some questions, Damon, about kind of what preceded this when we get a moment.
So Eric, what's our timer at here for tokens? About 13 and some change.
So we so it's 13 minutes and just a bit of change. The seconds scrolled off the screen, but about 13 and a half minutes, and that's having a copy and paste procedure. That doesn't count the months that Damon spent beating his head against a keyboard, hoping that the right magical incantation appeared on the bash prompt.
Well, can I ask, because it's important here in the time that we spent on it, we say copy and paste, like in the real world, someone may be copy and pasting from a tutorial. But tell me if I'm wrong, Damon, more specifically, what the video we're watching was a script that was run. Is that right? Okay.
Effectively, I was actually copying and pasting.
Oh, you were? Okay. That was my mistake.
Up until that final demo, which is a script itself. That was me copy pasting commands and typing a few by hand when I was feeling spicy.
Okay, you're feeling spicy. And I'll say, just as we talk openly, because I look and I go, wow, that was even faster like someone may sit here and go, yeah, 16, 17 minutes, not horrible. But as you call out, Eric, there's a lot of sort of learning that was into it. But Damon, I also wanted to chat, like when we started, we immediately went into a reboot, right? So there was at least one boot cycle in that.
I think there was 3.
There was 3.
There's depending on the exact system you go at, I don't want to mislead anybody, but there can be anywhere from 0 to 3 reboots, depending on if you have to, and to jump right into it, right? That very first thing that we did was blacklisting Nouveau and rebooting, right? If you've done GPU stuff, you know that if you're dealing with local hardware, you're basically always going to have that step. If you're in the cloud, if you're in Azure AWS, you might get spared needing to do that Nouveau blacklisting. But if you're on-prem, yeah, there's a reboot that's going to be part of it. You have to regenerate init RAM or Dracket potentially if you're dealing with secure boot. You're going to have to potentially install new drivers that have to be signed. That will be a whole other reboot right there. So it really adds up.
Yeah, because I'm sitting here going, man, I mean, like compared to what I experienced, that's not bad. Like, am I just really that inadequate? Did I miss something? And I don't expect you to testify that I'm not, but I wanted to.
For what it's worth, I wanted to present everyone in the best light, especially Ubuntu. So, right, that was a non-secure boot system, so that we could just install drivers and all that without an extra reboot. RLC Pro AI, even if it was a secure boot system, it would have worked out of the box, no reboot needed, right? With Ubuntu, no secure boot, great. We get to skip one of the reboots. But if there was secure boot, that's another reboot that an IT team or syseng has to worry about and deal with and coordinate.
Okay, and if I may, one more thing, Eric. Sorry, their DKMS was in there. You compiled KMods as part of that process.
For the Ubuntu stuff, they just kind of abstract and handle all of that. Again, right? Unless you're dealing with the secure boot ones where you need the signed packages, there's not a whole lot of rebuilding that you have to do, thankfully.
So that was pre-recorded, to be transparent, and that was months of work. And I got to go on. I got to sit in the sidecar as Damon went on this journey. And there were times where there was much yelling at clouds and long nights. But I wrote it down at 10 minutes and 32 seconds is when the demo switches from getting all the prerequisites set up to actually starting to work on our AI models. So with that in mind, a 13-minute demonstration, 10 and a half minutes was just set up. We've got another system here that is focused on RLC Pro AI. And our first step was not to blacklist Nouveau, but it was to actually just check and make sure that, oh, look, we see our card, NVIDIA SMI is working the way it should, which in my experience is always a challenge. But we just kind of dive right into, now we're doing pip installs, right, Damon?
Yeah, it's great. We not only are we going straight to pip installs, but we're going straight to transformers and accelerate, right? We're not dealing with that long torch build and compile that is what takes a really good chunk of time. We get to skip really far ahead. We're a couple of seconds in, and I'm already running the generate demo. There's no getting out of downloading those models. I'm sorry, guys. if I could preload all the models in the world, I would, but
but then there'd be a new model tomorrow and you wouldn't have it.
Exactly.
Well, and your base image would be terabytes in size.
Yes. This is the exact same demo, exact same code, just running on our Pro AI box.
So how much, Zach, how much does this change things for your clients, for yourself? Because I know you're an avid AI user yourself.
I mean, my time is very valuable. It is funny, like watching that first demo. This is actually the first time I saw it. And I see a lot of things that are familiar. And it's funny because it actually felt very good watching that, because like this is everything going right. This is the day you wake up and it's like, You show up at the train station right as the doors open, like everything just takes perfectly and is like, I've had that day occasionally where you start from a cold boot and you just go through the script and everything just works and you end, and 13 minutes later you're running your model, and that's awesome. That's great. It's really nice to not have to go on that journey every single time I've got a new machine that I want to start.
I will say the story that I'm sure Eric will enjoy is the story of filming that demo.
Oh gosh.
That involved me rebuilding the whole box from scratch like 3 times as I ran through it and did it wrong. And okay, nuke the whole box, start over, re-record, until I got that script into that. Again, that nice punch list of, okay, cool, I can just do this, do this, do this. It is a process.
Yeah. See, your demos required hardware interfaces where a lot of mine are virtual machines. And so after every few steps, I take a virtual machine snapshot just so I don't have to do that.
So here we go. We've got
already.
We've got our tokens already being generated.
We are sitting at 3 minutes and 2 seconds.
And Damon, can I ask, because this is also the first time I've seen versions of this demo, so I'm not acting for our audience, being that Damon and I work together. But I am curious, this appeared to actually be outputting tokens faster. Is it possible that that's the case here, or is that an illusion?
I'm gonna say that's probably just an illusion. They're probably roughly the same, but with everything else moving so much quicker, even that last little bit, right? But I think that's important to call out too, right? The user experience just feels nicer. It feels faster because you aren't spending so much time sitting around waiting for all those prerequisites to build, compile, and install.
Yeah. And the model download time is an especially painful one. Like, you can't avoid it, but it's very painful to realize you've got that model downloaded and you're like, oh, I got to wipe this machine and start over. And then you're like, well, I don't want to wipe this machine. I want to keep these weights around. And you kind of get yourself into this, well, you're not quite resetting the state of your machine to reinstall, and you can get really, really trapped. Like, it's nice to have your iteration loop be, you download the new model, you do inference, you look at the results, and you can iterate on what you care about, which is the AI, which is the models.
So Brian, I want to direct this next thought to you. Now that you've kind of seen the finished product, the finished demo that Damon's been working on, how do you feel that this scales? If you go from one node that we are working with to 50, how does this change things operationally?
Yeah, that is very interesting. Let me ask one thing for me, since I am admittedly new to this iteration of the demo. I know you guys had your stopwatch out. What was the time on that? On the Pro AI that we just saw?
The Pro AI video was about 3.5 minutes.
3.5 minutes from fresh install to inference.
Yep.
Okay. Yeah. So, and feel free to, correct me, jump in, or re-steer me. I'm going to say one thing about scale that is important and what we designed for here, in terms of choosing the open source drivers, versions of things that we pulled, flags that we configured in the CUDA stack, is one of the things that this does for you at scale is we've designed this to support the widest range of hardware as possible. And you asked earlier about infrastructure, right? One of the things that is happening that we're hearing about is that, people have to beg, borrow, and steal whatever GPU they can get. And there's oftentimes that if you go back to an Ampere generation GPU, it can work just fine for certain workloads. So, how do I at scale support a diverse fleet, right? How do I support my Blackwell? How do I support my Hopper? How do I support my Ampere? In a lot of cases, I'm hearing about people having to go through this process for each one. So one of this thing that enables you to do at scale is have one golden image for all of your GPUs, right? With mitigation of configuration issues you solve on the configuration time. And then that'll go to the next thing, right? when I have a validated stack, that supports the range of hardware, my older to newer, and I get to use it, then when I do scale that out, whether it be via IAC, Pixie Boot, or what have you, when I do scale that out, I am saved from the inevitable configuration errors that I'm going to find as I go across unique differences across sort of each of those nodes in my fleet and each of my servers. And so I'll just summarize, and I think there's other points or maybe other aspects to that question and to the answer, but I'll say it enables you to scale confidently and safely, mitigating the time that you have to spend iterating with your AI ML engineers, your SRE team, and debugging configuration issues.
Zach, any thoughts to add to that?
Yeah, I mean, it's nice to be able to use your old GPUs. Like you've got a machine sitting around with some consumer cards in it. I forget even the series, like the 2048. I don't even remember the numbers, but there's tons of people who have them. They were cheap at one point. You can put 4 of them in a box and do some interesting and decent stuff with it. And there's a lot of use cases where you're running smaller models, maybe not even language models. You're doing, interesting stuff with Torch. A lot of the image models are a lot smaller. And it's nice to be able to use your hardware. And sometimes you get to the point where it's like, well, the drivers are old, the machine's old, we can't figure out how to update things. So, we're just not going to use those cards anymore. And everyone's going to have to just make do with what we can get for newer hardware. So it's nice to let the useful life of these things extend out, because 1 year it's the absolute cutting edge. It's what you're running everything on. But as time goes on, you have these old hardware pieces that accumulate. You want to still be able to use them. They're still totally functional, but maybe the new software stack doesn't support it, and so they end up in the trash. And like, that's just wasteful, not to mention inefficient.
Damon, any thoughts?
Oh, many thoughts. And hardware support's always a challenge. NVIDIA, in their infinite wisdom, like to change how things get supported in their drivers for different cards, right? We can tell so many stories about the open drivers versus the proprietary drivers, and the data center drivers versus the consumer drivers and grid drivers. And there's all of these different configurations. And, heck, if you want to run really, really, really old cards, right? You want to run your old Voltas and Teslas. I think they finally dropped Volta support, but the Teslas and things like that, right? You need to know which things you got to grab, and it's always changing, right? NVIDIA is always updating that, and so it's nice to have someone else worrying about that, I think. It's even if it's not going to cover every single possible use case, every little bit helps. Every bit that we can extend the life of that hardware and the usefulness of it, and again, make that syseng life a little bit easier. Half of the folks have very heterogeneous fleets with all kinds of different hardware. And so, whatever we can do to make that a smooth, easy experience is, I think, just a win for everybody.
So if I wanted to try RLC Pro AI out today, where would I go to find it?
So that is, you read my mind. Thank you, Eric. So, a transition from scale is, look, if you're deploying production inference at scale, I will contend all the stuff we talked about is going to enable you to save time configuring and deploying. It is going to enable you to get more out of your GPU and use more of your fleet, right? And we'd love to talk to you if that's the case, right? If you're deploying 10,000, 10,000, if you're lucky enough, right, to have 10,000 GPUs across X number of nodes. But the reality is a lot of us are still on a learning journey. So I'd also say what we have built in, the easy setup time, is just as good for the researcher the individual user that is at the start of their journey. And that leads us to where we get this, right? Obviously, we are in the enterprise business. You can always just reach out to us. But what is awesome is one of the other things that the team has built and the team has announced this year is developer licenses, as well as trial licenses. So you can go to portal.ciq.com. There you'll see a range of our fantastic offerings that we have. And there you will be able to see Pro AI and get leads to securing it, of course, in the cloud across all major 3 CSPs, as well as getting QCals, ISOs, and soon containers. And for all of you who are interested in exploring and validating what we've talked about here today, you could simply sign up for a development license, download that, and use that. So portal.ciq.com.
Awesome. Yeah, that is the one-stop shop for everything that you need. There's links to documentation, links to contacting our sales teams, links to your tickets, and of course, all of those juicy, delicious downloads for not just Rocky Linux, not just RLC, but a lot of our other tools as well. So that brings us to the top of the hour. I really appreciate the 3 of you joining me today. This wouldn't be as much fun if it were just me talking into the void. So Brian, I really appreciate you joining me. Damon, actually, you and I will meet back here in a couple of weeks because just announced a couple of hours ago, I was so excited to get this email because now I can announce it live on air. But in 2 weeks from today, we'll actually be back right here, Damon and myself, and we'll be talking with Microsoft. So we've got a gentleman from Azure. His name is Hugo. He'll be joining us. Wait, Brian, are you on that one?
I am not.
Okay. I might drag you in anyway. But I know Damon and I will be back with Hugo, and we'll be talking about RLC Pro AI and what that looks like from a cloud perspective. We talked a lot about bare metal today, but let's face it, GPUs are hard to come by, and sometimes from a hardware perspective, it's just easier to let someone else do it. And I can think of no one better than Microsoft Azure to deploy those solutions, and nothing better than RLC Pro AI to run my AI models. I will, by the end of the year, be using AI to co-DM a Dungeons and Dragons campaign. That is the goal, and I'm using all of our technology to do it. So it's going to be really great, really excited. Zach, thank you for joining us, and we'll have to bring you back on real soon. Really appreciate your input and your insight, especially as someone who doesn't wear CIQ on their badge.
I was very happy to be here. I love the conversation.
Yeah, it's a lot of fun. I should have teased Brian more, but you know what can you do? But for those of you that joined us live, really, really appreciate it. Appreciate the conversation in chat. If you didn't catch us live and you're watching this on YouTube, there's a comment section down below, and I check those a couple of times a day. So if you have any questions, if you have any comments or insights, feel free to put those into the questions below or into the comment section below. If you are catching this after the fact, make sure you hit the like button. That kind of helps juice the algorithm, and subscribe because we've got a pile literally of about 15 videos that are almost ready to publish. They're in final editing. So there's a ton of demos, thought leadership, product overviews, all kinds of cool stuff coming to our YouTube channel. So definitely subscribe for that. And yeah, so got new videos, new webinar, and then a few of us will actually be at Linux Fest Northwest in a couple of weeks alongside our friends over at Rocky Linux as well. So lots to do, lots going on.
And also important, catch us at HumanX next week.
HumanX, yes.
Audits may be there. We'll be out on the floor, and we'll be happy to show this to you.
Yeah. I think Brian and Hope, one of my counterparts, will actually be at HumanX next week. So if you'll be there, make sure to stop by the booth. We usually have some fun swag and, of course, a team of experts to answer all of your questions. With that said, on behalf of my guests, Brian, Damon, and Zach, I've been Eric the IT Guy Hendricks. On behalf of CIQ and our webinar team, really appreciate you all tuning in, and we'll talk to you again real soon.
Thank you. And thank you guys for helping build this.